Hi folks, this is Calc 3 Checkpoint Quiz 2. We're asked to state the limit definition of the derivative r prime of t. So, just like any other derivative, it's a rate of change. We're going to look at the change in the function, which would be delta r, over the change in the inputs, delta t, and we'll take a limit then as the delta t goes to 0. So this is an average rate of change. We tack on the limit, we get the instantaneous rate of change. So r prime of t is the limit as delta t goes to 0, r of t plus delta t minus r of t over delta t, provided this limit exists. And so that's the limit definition of derivative, and that'll do it for number 1. Okay, on to number 2. We're asked to find the derivative for this vector valued function. So the first thing I'm going to do is rewrite this so it makes a little bit more sense. I have a vector divided by a scalar. What's that really mean? Well, that really means to take the scalar 1 over the square root 4t squared plus 1 times the vector 2t1. And since we're getting ready to take the derivative, I'm going to rewrite this first factor as 4t squared plus 1 to the minus 1/2 times this vector 2t1. And so if I look at this, I've got a form of a scalar function f of t times a vector function, say g of t. And so we do have a product rule that applies. You want to take the derivative of a scalar function times the vector function. It's just like the product rule you know from Calc 1. You take the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. So that carries over from Calc 1. And so here we go. R prime of t equals, I need to take the derivative of the f of t. So the derivative of the f of t is minus 1/2 4t squared plus 1 to the minus 3/2 times the derivative of 4t squared plus 1. That's all the derivative of the scalar function. Multiply that by the vector function 2t comma 1 plus the scalar function 4t squared plus 1 to the minus 1/2 times the derivative of the vector valued function. And how do we take derivatives of vector valued functions? Each component at a time. So the derivative of 2t is 2, the derivative of 1 is 0. So to finish this, I need to take the derivative of 4t squared plus 1. That's going to be 8t. I have a negative 1/2, so I have a negative 4t times 4t squared plus 1 to the minus 3/2 times the vector 2t1 plus 4t squared plus 1 to the minus 1/2 times the vector 2, 0. So now what remains is a bunch of cleanup. Some good old-fashioned algebra. Okay, so here's our unsimplified derivative. Now we want to simplify it. And it all depends how you were brought up mathematically. Some students like to rewrite these as denominators and get a common denominator. Some students like to factor out what's in common. So in this case, we would factor out 4t squared plus 1 to the negative 3/2. I'm going to go ahead and use the factor approach. So when you factor out what's in common, remember from algebra, you always factor out the smallest exponent. So in this case, I'm going to be factoring out the 4t squared plus 1 to the minus 3/2. So if I do that, in the first term here, I'm going to be left with the negative 4t times a vector 2t1 plus. When I factor it out of here, remember I'm going to be subtracting the exponents. So negative 1/2 minus a negative 3/2 gives me a positive 1. So I've got the 4t squared plus 1 to the minus 3/2. Let's see what I have going on in here. I have a negative 8t squared, negative 4t, plus 8t squared plus 2, 0. So I'm just multiplying these scalars to each of the components. I add that up, once again component-wise, and inside what do I get? 2 comma negative 4t. And so I can rewrite that as 2 comma negative 4t divided by 4t squared plus 1 to the 3/2. Or I could go one step further to simplify. That's 2 divided by the quantity 4t squared plus 1 to the 3/2 comma negative 4t squared plus 1 to the 3/2. And so that'll do it for number 2.